Welcome. This is Columbia Basin Research's second video in a multi-part series on using Program User, which stands for User Specified Estimation Routine. User is a program created by Columbia Basin Research at the University of Washington School of Aquatic and Fishery Sciences with funding provided by the Bonneville Power Administration. Today, in this second video, we'll be looking at the one likelihood example, a simple method for estimating the number of animals in a closed population using a single mark recapture of individuals, also known as the Peterson Method. A sample of N1 individuals is taken from the population and marked for future identification and returned to the population. After some interval, a second sample of N2 individuals is taken and it is found that M of them are marked. We are interested in estimating the parameter N, the number of animals in the population. Let's fire up the program. Type user into the search bar or click the program user icon on your desktop. For this example, we will use the following expository data. N1 equals 220, N2 equals 235, and M equals 40. If we let P represent the proportion marked after initial tagging, then P equals N1 divided by N. Assuming that the proportion of marked individuals in the second sample is a reasonable estimate of the proportion marked in the population, then the probability that an animal in N2 is marked is P. The categories and their corresponding probabilities of occurrence are as follows. Category M will have a probability P, and category N2 minus M will have a corresponding probability of 1 minus P. The resulting likelihood is as follows. On startup, we find ourselves with the parameters content page active on the user dialog. In this example, we have one parameter to estimate, N. So we place the cursor in the first cell of the parameter definition table and type N, press Tab to move to the next cell. Notice that after entering the parameter N, two asterisks appear in the title window after the version number. This indicates that there are unsaved changes to the workspace. Use the Save Workspace or Save Workspace As commands to save your work to a workspace file. If you then exit user and start it up again, you can use the Load Workspace command to pick up where you left off. From the Parameters content page, press the Next button or double-click on Convenience Functions on the navigation panel. This will make the Convenience Functions content page active. Convenience functions allow a user to define a symbol as a substitute for a function of the parameters and/or other convenience functions, or, as in this case, a substitute for a constant value. Convenience functions are optional, but they can be useful in making it easier to define the likelihood and make the likelihood more readable and flexible. The likelihood, for this example, uses the value N1, which in this case is 220. We could simply use the number 220 directly in the likelihood. Instead, we will define it as a convenience function. In the first row, under Name, enter N1. Tab to the definition column and enter 220. Next, we define P as N1 divided by N. In the second row, enter P for the name. In the definition column, enter the function N1 divided by N. You could simply type in N1 divided by N as I've done here, or you could use the shortcut buttons on the toolbars on the top of the convenience functions page. The topmost toolbar provides some commonly used mathematical operators. The second toolbar provides the parameter names, and the third toolbar provides the names of the convenience functions defined so far. Thus, an alternative way to enter the definitions for P is as follows. With the cursor in the definition cell for P, click N1 on the third toolbar. Then click on the divide symbol on the top toolbar, and then click on N on the second toolbar. Press Next to go to the likelihood definition page. Each likelihood consists of two or more mutually exclusive and exhaustive categories. From the previous equation and the mark recapture data previously mentioned, we can define the categories as follows. Label M, probability P, and count 40, and label N2 minus M, probability 1 minus P, and count 195. Pressing the next key from the likelihood definition page makes the verify the model page active, verifying that 1, there are no undefined symbols used in the likelihood definition, and 2, the probabilities of occurrences sum to 1.0. The verify the model page also displays the number of parameters and the dimension of the minimum sufficient statistic. If the dimension is less than the number of parameters for a model with one likelihood, parameters may not be estimable. If everything has been done correctly, the user dialog should now appear. If there are any undefined symbols or if the probabilities do not sum to 1.0, you will not be able to estimate the model parameters. If everything checks out, click Next. We have now finished the model definition phase. The parameters and likelihoods are defined, and we move on to the estimation phase. The Next button takes the investigator to the parameter seeds content page. Parameter estimation in user is performed by maximizing the likelihood function using numerical optimization. All numerical optimization procedures require initial seeds or starting points for the parameters. User uses a default value of 0.5 for all parameter seeds when those parameters are expected to be between 0.0 and 1.0. In this case, however, the parameter to be estimated is animal abundance, so we need to change the seeds to be a more reasonable number. A good rule of thumb for seeds in this analysis is to add up to a unique number of animals observed as a minimum population size, so 220 plus 235 minus 40 equals 415. Pressing Next leads to the next content page, Profile Likelihood Confidence Intervals. A profile likelihood confidence interval is estimated for each parameter at each one alpha level selected individually. This means that for larger, more complicated likelihoods, each estimate may take a while to estimate, and that it is recommended to do them one at a time rather than selecting all desired estimates at once. No profile likelihood confidence intervals will be requested for this example, so proceed to the Optimizer content page by clicking Next. The next content page is titled Optimizer and allows the user to specify the numerical optimization settings. The default optimizer is called Powell's direction set. Another standard optimizer is Fletch, which uses quasi-Newton-Raphson method to numerically solve for the parameter estimates. In most cases, it is sufficient to use default settings. Check the Use Previous Estimates as new seeds to automatically update the initial seeds to the last iteration results if you rerun the program. The Calculate Covariance matrix is required if you want standard error estimated for each of the parameters and convenience functions. If your likelihood still appears to be getting smaller but is not converged when the program stops, you may want to increase the maximum iterations. This will increase the running time of the program. Other suggestions are to decrease precision, allowing the program to try a larger parameter space, and increase proportion step size. Once the program finds parameters that converge, the precision and proportional step size can be reduced to try to increase precision. The next content page is the Estimate Model Parameters page. This is where, after defining the model, specifying the counts, and setting up the optimizer, the parameters are actually estimated. Press the Estimate button on the upper left, and the output of the optimizer will appear in the text area of this content page. If the model parameters are successfully estimated, the Workspace Locked indicator will appear in the lower right. This means that you can no longer make any changes to the workspace, parameters, convenience functions, likelihood definitions, counts, without first explicitly unlocking the workspace. This ensures that the model results and diagnostics are consistent with what appears in the model definition section, and that you don't accidentally overwrite your results. If you wish to make changes, you must go to the Clear Current Estimates command under the Action menu. This will erase all current estimation results. If you left the parameter seed at the default value of 0.5, pressing the Estimate button might produce something like what we see here. If the seed is bad, the optimizer may fail to find parameter estimates. If this happens, go back to Parameter Seeds content page and change the seed. Complex models may take some trial and error to find the appropriate parameter seeds. The next content page, under View the Estimates, is titled Estimation Summary. It summarizes the results and provides the categories with their corresponding counts, the parameter estimates along with their standard errors if Calculate Covariance matrix was selected, the convenience function estimates along with their standard errors calculated using the delta method, and any requested profile likelihood confidence intervals. The next three pages, parameter estimates, convenience function estimates, and profile likelihood estimates, are provided as alternative ways to save the information initially developed in the estimation summary page. Each allows the user to cut and paste the results into a Word or Excel file or save it as a CSV file. These estimates will have greater precision than the displayed estimates rounded for readability. The covariance matrix is provided to enable estimating the variance of combinations of parameters, though this may also be possible to estimate by using convenience functions. The correlation matrix gives the estimated correlations between the parameters in the model. View the Model Diagnostics contains 3 pages of plots that may help in determining model fit. Large differences in the expected versus observed data or large residual for particular estimates will warrant a closer look at the model and the data. This has been Lesson 2 on using Program User, in which we covered 1 likelihood examples. Future videos will cover joint likelihood, abundance estimation, and hypothesis testing examples. We hope that this video helps you get the most out of Program User. Again, if you have any questions or comments in regard to Program User, please fill out our survey as previously detailed. You can also contact Columbia Basin Research at web@cbr.washington.edu. Best of luck on your estimation routines, and thank you.